What's up? I'm Vin, and today I want to go through this 2023 New York math test for grade 5, and I'll leave a link to a copy of this test in the description below. Now let's get started. Question 1, there is 7/8 of a whole pizza in Anthony's refrigerator, and he eats 3/8 of the whole pizza for lunch. And we want to know what fraction of the whole pizza is left after Anthony eats pizza for lunch. So we're starting out here with 7/8 of a whole pizza, and then Anthony eats 3/8 of the whole pizza. So when you eat the pizza, you would subtract that from the original amount here. Now, keep in mind here that there isn't a whole pizza in Anthony's refrigerator. There's 7/8 of a whole pizza. So if we want to visualize what's going on here, we have this pizza, okay, and there are 8 slices. And for some reason, somebody just ate one slice and then put the rest of the pizza in the refrigerator. I don't know. Me personally, I feel like I would have ate more than just one slice if I had a fresh pizza. But whatever, this is the question. So 7/8 minus 3/8. So if Anthony eats 3 slices, and remember, one was already missing, then there's going to be 4/8 left. We have 1, 2, 3, 4. Or if we just do the subtraction here, we would have 7 minus 3 over 8, and we can combine these into a single fraction because these fractions have common denominators. And if we do 7 minus 3, that's going to give us 4/8. So we have, there is 4/8 of the pizza left after Anthony eats pizza for lunch. Now, this question is a little bit sloppy. I would like to see them reduce this fraction here and divide the top and bottom by 4. And then this would reduce to 1/2. We could see that half of the pizza is remaining. But in this case here, we don't have to simplify. So choice C is our answer. Question 2, what number represents 99 thousandths? So 99 thousandths would be 99 over 1,000. And this, if we want to convert from fraction form to decimal form, and we have a 1,000 in the denominator, what we're going to do is we're going to write this as 0. And then we're going to have 0.99, okay? One little trend to notice is, let's say I do 99 divided by 10. The math that I'm doing in my head when I divide by 10 is I move the decimal one place to the left. So if I do 99 divided by 10, I'm taking the decimal and I'm moving it one place like this. And that would give us 9.9. If we were to divide by 100, so 99 divided by 100, then we would move the decimal 2 places. So it would move once more and it would make 0.99. Okay, so 99 over 100 would be 0.99 like this. So doing 99 divided by 1,000, I would just put a placeholder here, another 0. I would move the decimal once more. So I would move it 1, 2, 3 times, and that would give us the 0.099 like this. Okay, so scanning through the answer choices, we can see that our answer matches up with choice A. Question 3, we have a shipping box in the shape of a right rectangular prism, and the shape has a base with an area of 16 square feet and a height of 6 feet. And we want to know what is the volume in cubic feet of the box. Well, for this question here, we could just go ahead and draw something out here, and we don't necessarily have to draw something to scale. We just have to draw something here that looks like a rectangular prism. So this is just going to help us imagine what's going on in the question. So this question is a little bit tricky because what they told us was they told us that the rectangular prism has a base with an area of 16 square feet. So they're telling us the area of the bottom here. Now, you might recognize the formula for the volume of a rectangular prism as volume equals length times width times height. However, there is another way to find the volume of a rectangular prism. We could say the volume is equal to capital B times H, where capital B is the area of the base. Okay, so the area of the base. And since it's a rectangular prism, we could look at the base and say, oh, the area of the base, if the base is a rectangle, is length times width. Okay, so that's where this is coming from. The capital B, the area of the base, is the length times width, and then we just multiply by the height. So this second formula is going to be the one that's the most helpful here. So if we have the area of the base is 16 square feet, I have 16 square feet, and then I multiply by the height is 6 feet. Now I just multiply these numbers together. I do 16 times 6 is 96. And then if I do feet squared times feet, that's going to give me cubic feet like this, okay, since we're talking about volume. You can just write the units at the end, but once again, area is in square units, and the height is in just regular feet to the first power. Okay, so a distance we're talking about when we're talking about height. But at the end, the volume is going to be in cubic feet. And if we have to do this multiplication by hand, we would just do 16 times 6. And we have 6 times 6 is 36. We carry the 3. 6 times 1 is 6, plus 3 is 9. So that's where choice B is coming from. Question 8, we want to know what number has the same value as 32 times 10 to the 4th power. And when we want to convert from scientific notation back to standard form, what we want to do is move the decimal this many places to the right. So whatever the power of 10 is, we're going to move the decimal that many places to the right. So I'm going to go 1, 2, 3, 4. All right, that's why I put a bunch of extra zeros here. And the decimal would land over here. So I'd have 3, 2, and then 4 zeros. And now I'll just put my comma every 3 digits here. So I have 3 digits going from right to left. So I put a comma, and then I just look for 320,000. This is going to match up with choice D. If you want to do this the longer way, what you could do is you could just multiply 10 to the 4th power is 10 times 10 times 10. So I'll just multiply 10 by itself 4 times. And if I multiply like this, I just have 1 times 1 times 1 times 1 is 1. And then I have 4 zeros. So what I could do here is I could just multiply 32 by this number here. Okay, so I can multiply 32 by 10,000. And if I do this long multiplication here, I should get the same answer. So I just do 2 times these 4 zeros. And then I do 2 times 1 is 2. I put a placeholder, and then I have 3 times 0, and I do it 4 times. So 1, 2, 3, 4. And then I do 3 times 1 is 3. And now just add everything up, and notice that we get the exact same answer. Okay, we're going to get 320,000. So choice D is definitely our answer. Question 9, which model is shaded to represent the area of a rectangle that is 4/5 centimeters long and 3/10 centimeters wide? So for this question here, there's a few different ways we could approach this, but we're looking for a shaded section here that, once again, goes 4/5 of the way across and then 3/10 of the way down. So looking at this, choice B jumps out at me right away because look across the top here. There's 1, 2, 3, 4, 5 spaces, and 4 of them are shaded out of the 5. So you see the 4/5? This is being modeled over here across the top, going from left to right. If I number this way, 1, 2, 3, and then I just count all the way down, this is going to number up to 10. And notice that shaded this way, we only have 3 out of the 10 shaded this way. So if we're looking for which model is shaded to represent the area of the rectangle that is 4/5 centimeters long and 3/10 centimeters wide, choice B would be it. Okay. The problem with choice A is that it's shaded 1, 2, 3, 4, 5/5. Okay. It's going 5/5 across like this, which is exactly 1 centimeter. So that's why this answer choice is no good. Now going this way, it is 4/5 centimeters long. However, going down this way, if we count all the way down to 10, it is 10/10 centimeters wide. Okay. So this would be 10 over 10 centimeters wide. So that's why choice C is no good. And then this one here is just all out of whack. This doesn't even make a rectangle, so we could just chop that answer choice right away. And then one other cool way of seeing this would be to do the multiplication. The area of a rectangle we could find by doing the length times the width. And if I write in those fractions here, we have 4/5 centimeters going this way, and then we have 3/10 centimeters going the other way. And now we work this out. We're just multiplying these two fractions together. And remember, anytime you multiply two fractions, you could just multiply their numerators and their denominators. So I would do 4 times 3 over 5 times 10. And the units here would be square centimeters. And now if we work this out, this would make 12 over 50. And notice what we have here. There's 1, 2, 3, 4, and then I can just keep counting up to 12. There are 12 boxes shaded, and let me just make this a little bit neater. So 12 out of 50. There are 12 boxes shaded out of 50 total. Okay, so this is really supporting here that choice B is definitely our answer. Question 10, a mall parking lot has 2,232 parking spaces, and there are 24 parking spaces in each row. How many rows are there in the parking lot? So for this question here, what I'm imagining is we have a bunch of rows, and we don't know how many rows there are, but we know there's a bunch of them. And each row has 24 parking spaces. And we want to know how many rows are there if there are 2,232 parking spaces in total. Well, what I could do is I could take 24 and multiply it by the number of rows, which we don't know, and say that that's equal to 2,232. Okay, this we can say. So if I want to solve for the mystery value here, I have to know the opposite relationship between multiplying and dividing. Let me use easier numbers. If I say 5 times 7 equals 35, I can make two statements with division here. I could say 35 divided by 7 equals 5. Or I could say 35 divided by 5 is equal to 7. So here, if I want to solve for this mystery value, I could use that opposite relationship and I could just do the division. I could do 2,232 and divide by 24. Now from here, 22 is not divisible by 24 because 24 is greater than 22. So I'd have to go out 3 places to 223. And this I'm going to approximate and say will go in 9 times. The reason I'm able to come up with this number, or what I'm thinking of to come up with this number, is I know that 24 times 10 is 240. Okay, I just throw a 0 at the end. And I know that 223 is really close to 240. Okay, those two numbers here, if I do the subtraction, are 17 away from each other. Okay, so that tells me if I go times 9, that's going to get me as close as possible to 240 without going over. And now on the side, I would just do 24 times 9, and I'm going to have 9 times 4 is 36. I carry the 3. 9 times 2 is 18, plus 3 is 21. So we are subtracting 216. And now from here, we borrow, and we have 13 minus 6 is 7. The rest cancels, and now we bring down the 2, and 24 goes into 72 evenly 3 times. If I do 3 times 24, I'm going to get 72, and I subtract, and I have no remainder here, okay? So this tells me that 93, choice B, is our answer. Question 11, a teacher has 20 feet of string to use for a class project, and she uses all of the string and gives an equal amount to 8 students. How much string in feet will each student get? So if the teacher has 20 feet of string, and she's going to share it equally amongst 8 students, we're going to do 20 divided by 8. Okay, 20 divided by 8. And for this, I could just do the long division on the side. 20 divided by 8. 8 goes into 20 twice. 2 times 8 is 16. We subtract 16, and we have a remainder of 4. But we are originally dividing by 8, so I write my remainder over the divisor. And now this, I could just simplify. So now we are simplifying. 4/8, I could divide top and bottom by 4. But notice that this is the same fraction as before with the pizza problem. So we have 2 and 1/2. Okay, we scan the answer choices, and this will match up with choice C. Question 14, here's a nice place value question. We want to know what digit will be in the tens place after 8,642 is divided by 10. Well, remember, when you divide by 10, the shortcut is that you just take the trailing decimal at the end. And if there is no decimal written, just write 0.0 and you move it 1 space to the left. Okay, so we're just going to move this 1 space to the left, and this is going to give us 864.2. And now what we're looking for is what digit will be in the tens place. So just know the names of the places. This is the ones place. This is the tens place. And then this over here would be the hundreds place. Okay, so the hundreds place. And now these are a little bit tricky to spell. Next would be, if I went this way would be the tenths place. If I wrote a bunch of zeros after, this one would be the hundredths place, which is the word hundred with a THS at the end. And then this one here would be the thousandths place. So 1,000 and then place. Sorry, that's hard to say. All right, so we're looking for which digit will be in the tens place. So the tens place is right over here, would be a 6. Okay, so that's going to match up with choice C. Just be careful here. It's very tempting to choose choice A, mixing up the tenths and the tens place, but the tens place is once again right over here, so choice C is our answer. Question 17, which expression has a value less than 1.5? And notice that all of the answer choices start with 1.5 and are being multiplied by something. So if you want to take something and make it smaller, you want to multiply by something that is less than 1. Okay, so if we want something to pop out less than, then we multiply by, I'll say, times a number. So times a number that is less than 1. Okay, so that is less than 1. So here, just looking at the answers, I could see B is our answer right away. And just think about this carefully. Like, let's say you have $10. Okay, so this, just think about it. You have $10, and then someone takes your money and they say, you know what, I'm going to take half of your money. All right, which would be sad. Hopefully no one actually takes half of your money. But we multiply your money by a half. Now you have $5. You have something less than what you started with. This is just a little bit trickier because you're multiplying a mixed number by a half, but the concept is still the same. That if you multiply your money by a half, now you have half your money, so you have less than what you started with. Unless we're talking about debt, negative dollars, but don't worry about that, okay? We're talking about a positive number here, so we don't have to worry about any funny business. Getting half of your debt wiped out would actually be a good thing, but when we're talking about positive dollars, losing half your money is always sad. Okay, so choice B would be our answer. Now, the reason why choice A is no good is if we multiply by 3 over 2, this number is greater than 1. Okay, so anytime you multiply by a number greater than 1, that's making the amount greater, okay? Unless we're talking about negatives again, but we're not worrying about negatives just yet, okay? So I'm going to get rid of this answer choice. If we have 1.5 and we multiply by 2, that would be like taking your $10 and someone says, you know what? I'm going to double your money, so now you have $20. Okay, so you'd have more money than what you started with. And if we multiply by 1, then you're all the same. It's just going to give you the same amount that you started with. Doing times 1 doesn't change anything. Okay, so that's why choice D is out. Definitely choice B. Question 18, we have a diagram of 2 right rectangular prisms, each made with unit cubes, and they're both shown below. And we want to know what is the total volume in cubic units of prism A and prism B. Now, these are right rectangular prisms, and the volume of a right rectangular prism is length times width times height. Okay, that's the formula that we're going to use here. So now we just have to count the dimensions here. We're going to count the length, and we'll say that's the distance going across, is going to be 3. Notice that we're going 1, 2, 3 across like this. So the length of the first prism we're going to say is 3. We'll just make that neater. And now the width we'll say is going this way is 1, 2, 3. And then the height is, notice we're just going up one length like this. So we have a 3 by 3 by 1. So now the volume that we're going to have in total, the volume of the first prism for prism A, I'll just write that over here, is we have 3 times 3 times 1. And the units here are just cubic units. So I'm just going to not write the units and worry about the number. And then we have plus, because we want to know the total volume in cubic units of prism A and prism B. Okay, so that means we're going to add these two together. And now for prism B, notice that this is a cube. It's going 3 across, 3 back, and 3 up. So if we find, or we multiply here the length, width, and height, we're doing 3 times 3 times 3. Now, just remember your order of operations, okay? PEMDAS. Please excuse my dear Aunt Sally, but this tells you to do parentheses exponents first, then we do multiplication division, and then we do addition subtraction. So the fact that we have multiplication and addition, we're going to do the multiplication first. So we have 3 times 3 is 9, and then times 1 is 9. Plus, if I do 3 times 3, that's going to give me 9, and then 9 times 3 is 27. Okay, the math that I'm doing in my head for that, if that's a little tricky, is when I do 3 times 3 times 3, I'm multiplying these two numbers first to get 9, and then 9 times 3 is 27. Okay, so that's where this is coming from. And then 9 plus 27 is 36, so choice D is our answer. Question 20, the total snowfall for a town from Friday through Sunday was 34 inches. Okay, so this was the total snowfall. And then we have on Friday, the snowfall was 11.25 inches. On Saturday, the snowfall was 9.9 inches. And we want to know how many inches of snow fell on Sunday. So for this one here, we just have to think about this. The total amount of snowfall, we would have to do Friday plus Saturday plus Sunday. And this would give us the total. Okay, so this is the idea of what's happening. So here, what I want to do is I'm going to first add how much snow fell on Friday and Saturday. So I'm going to do 11.25 plus 9.9. Okay, and I'll just put I'll put a 0 at the end of 9.9 so that we could see how the place values all line up. So 5 plus 0 is 5. 2 plus 9 is 11. Carry the 1, and we'll just drag this decimal down. And now we have 1 plus 9 is 10. Plus 1 is 11. We carry the 1. And then 1 plus 1 is going to give us 2. So now think about what are we going to do with this number? and this total over here. Well, think about the big idea. We're doing Friday plus Saturday plus Sunday. This is the mystery amount, is going to give us the total 34 inches. Okay, so far what we have is we have Friday and Saturday and we have the total. So if we want to know how much snow fell on Sunday, we could take the total and subtract how much snow fell on Friday and Saturday. Okay, so I'm going to subtract this, and I'm going to put a 0.00 here so we could do the long subtraction. And now we're going to borrow from here and get a 3. That makes this a 10. We borrow from this and make it a 9. And now I'm doing 10 minus 5 is 5. 9 minus 1 is 8, and I put my decimal. 3 minus 1 is 2, and then 3 minus 2 is 1, and we get 12.85. Choice A is our answer. Now, if you want to check your answer just to make sure you did this right, what we could do is we could add up these 3 totals just to make sure that we did the subtraction right. So we add up the 3 totals, and I'm just going to put place values here to match everything up. And if we add this stuff up, notice here, we get 5 plus 5 is 10. We carry the 1. And then we get 9 plus 1 is 10, 8 plus 2 is 10, and 10 plus 10 is 20. So we get a nice even, a bunch of zeros at the end here. And now we can make groups of 10. 9 plus 1 is 10, plus 2 is 12, plus 2 is 14. Carry the 1, and then 1 plus 1 plus 1 is 3. And notice that we get our 34 inches. Okay, we could have also just added the answer choices to these 2 numbers, but this is a way more conceptual approach. And once again, this was just to check our answer. So our answer is definitely looking good here. Question 21, we have Dorian walks at an average speed of 2.5 miles per hour, and he walks for 3/4 of an hour. And we want to know how many miles does he walk. So for this question here, if you really just get the concept, you'll see that we're just going to multiply 2.5 by 3/4. And the reason behind this is if I draw out a visual diagram over here to model the situation, this is what I imagine. So here's Dorian. So I'm just draw Dorian a little bit neater. So there's Dorian. Okay, going on a walk. And Dorian, we know, goes an average speed of 2.5 miles per hour. Okay, so when Dorian walks, that means he's going to cover 2.5 miles after 1 hour goes by. Okay, so 2.5 miles he could cover in 1 hour. So if we go to, let's say, the halfway point, that would be if half an hour went by, we would take 2.5 and we would divide it by 2. All right, now 2.5, I could convert this to an improper fraction by doing 2 times 2 and then plus the numerator value 1 over my original denominator is 2. And that gives me 2 times 2 is 4 plus 1 is 5 over 2. Okay, so I get 5 over 2 is the improper fraction form of this. But if I multiply by a half, this gives us 5/4. And if I do the division here, 5 divided by 4 is 1 with the remainder of 1. So I get 1 1/4. Okay, so if you think about this, half the distance to 2.5 is 1 1/4. And that would take Dorian a half hour. So if Dorian is walking for 3/4 of an hour, do you see that 3/4 of an hour would be at this location over here? Okay, if we break this up into fourths, this would be 1/4 of an hour. 2/4 of an hour equals a half, and this would be 3/4 of an hour right here. So we're really looking for how much distance does Dorian cover in this time, but that we could find by just multiplying the total by 3/4. So that's why we're multiplying by 3/4. So we converted 2.5 into an improper fraction. So we could just use that over here. We could say 5 over 2 times 3 over 4. And now we work this out. 5 times 3 is 15. We'll just make that a little neater. So we have 15 over 2 times 4 is 8. And now I just do the long division. 15 divided by 8. 8 goes into 15 once. 1 times 8 is 8. Remainder 7. And we originally divided by 8. So this is 1 7/8. So this would be the 1 7/8 mark over here. So 1 7/8 miles is the distance that Dorian covers in 3/4 of an hour. So choice B is our answer. Question 26, we have Miss Roman buys 3.5 pounds of birdseed and she pays $4.28 per pound. And we want to know how much did Miss Roman pay for all of the birdseed. So for this question here, we could just multiply 3.5 by 4.28, okay? But where I'm coming up with this, I just imagine 3.5 pounds. So I have, let's say 1, 2, 3, and then we have half a pound here. And each pound is $4.28. So that's $4.28 3 times for each pound. But then for the half pound, we could just divide 4.28 by 2, and that would be $2.14. Okay, if I just divide by 2, 4 divided by 2 is 2, and 28 divided by 2 is 14. So that's where this is coming from. So we could just take these numbers here and add them all up. Maybe you would find that math to be easier. Okay, so this is one approach to the question, is that we could just take 3 of the $4.28, and then we take one of them and cut it in half, and then we just add this all up. And this would tell us how much it cost for the 3.5 pounds of birdseed. Okay, so we could just use this addition here. 8 plus 8 plus 8 is 24, plus 4 is 28. Carry the 2, then we have 2, 4, 6, 8, plus 1 is 9. And now we have 4, 8, 12, plus 2 is 14. So 1498, choice D is our answer. Or what you could do is you could do 428 times 3.5. But what I like to do for this, if I have to do 4.28 times 3.5, what I like to do for situations like this is I like to do the multiplication on the side as if it were just 2 whole numbers. And then I use that to tell me what I need to know over here. So I do 5 times 8 is 40. I carry the 4. 5 times 2 is 10, plus 4 is 14, carry the 1. And then we have 5 times 4 is 20, plus 1 is 21. And now I put a placeholder. I have 3 times 8 is 24. I'll get rid of this. I carry my 2 from 24. 3 times 2 is 6, plus 2 is 8. And then we have 3 times 4 is 12. Okay, now we add this all up. So I have 0 plus 0, 4 plus 4, 8 plus 1 is 9, and I have 2 plus 2 is 4, and I have a 1 here. And looking at this, this will help me come up with my answer to the decimal problem. Notice that I ignored 1, 2, 3 decimal places. You see, to build this number, I would have to give 1, 2, 3 decimal places total to build this. So I just have to move the decimal 1, 2, 3 times like this, and that would give me 14.98. But once again, if you think this math is easier to do, to just take 3 pounds and then cut the fourth one in half and just take half the amount and then add, that's also fine. But either way, we're getting choice D. Question 29, we have a store sells packages of black pens, blue pens, and red pens. 4/9 of the packages are black pens. And then we have 1/6 of the packages are blue pens. We want to know what fraction of the packages are red pens. So for this one here, the first thing I would do is add 4/9 and 1/6. So here we need common denominators, and the best common denominator to go with would be 18. We want the least common multiple between both of those denominators. So if we count by 6s, notice that we get to 18 at this part here. And if I count by 9s, I get to 18. This is the first number that they both have in common. Yes, we could keep going. So we could go to, let me just go here. So we have 30 and then we have 36. So they would match at 36 as well, but we want the least common multiple. That'll make this as nice as possible. So here I'm going to do times 2 over 2, and here I'll do times 3 over 3 to make common denominators. And now we have 2 times 4 is 8, over 2 times 9 is 18, plus 1 times 3 is 3, over 6 times 3 is 18. And now I have 8 plus 3 over 18. Remember, when I have common denominators, I just add or subtract the numerators, and I keep the denominator the same. And then 8 plus 3 is 11, so I have 11 over 18. But remember, this accounted for the black and blue. Okay, so this was the sum of the black and the blue, but altogether, the store sells packages of black, blue, and red. Okay, so from here, we want to know what fraction of the packages are red pens. So just know here, if we're talking about all of them together, this is one whole. Okay, all of the fractions together make one whole. So the missing part of the fraction here is for red, but there's one whole, so I have to do 1 minus 11 over 18. And what I could do here is I could just call this 1 over 1. Okay, I'll just make that, let me erase that, make it look nicer. So I could say 1 over 1. And if I want a common denominator here, I could just multiply this first fraction by 18 over 18. And now this gives us 18 over 18. So we have 18 over 18 minus 11 over 18. And as a single fraction, I could say 18 minus 11 over 18. And 18 minus 11 is 7. So I get 7/18. Choice B is our answer. Question 31, we have a diagram of a right rectangular prism made of unicubes is shown below. And we want to know what is the volume in cubic units of the right rectangular prism. So for this question, we're using this formula again. Volume equals length times width times height. And now we just have to count the units going in each direction here. So across here, we could call this the length. We're going 1, 2, 3, 4 spaces. And then going back, we're going 1, 2, 3, 4, 5, 6. And then going up, we're going 3 units up. So here, the volume, we could say, is the length, we'll say is 4, times the width over here is 6, and then times the height is 3. Okay, now I could use times like this. I could write 4 times 6 times 3. But just know in math, parentheses means multiply. Okay, so I could also write the product like this. So now I'm doing 4 times 6 is 24. And then I have 24 times 3. And this, I'll do the long multiplication over here. So I have 24 times 3. 3 times 4 is 12. We carry the 1. And then we have 3 times 2 is 6 plus 1 is 7. So 72 cubic units. That is the volume of this rectangular prism. Choice D is our answer. Question 33, we have Diane walks 3 3/8 miles on Saturday, and she walks 1 5/6 fewer miles on Sunday than she does on Saturday. And we want to know how many miles does Diane walk on Sunday. So for this question, what we're doing is we're going to take 3 3/8 and we're going to subtract 1 5/6. Okay, and the key phrase here is that she walks this many fewer miles. Okay, so that tells us to subtract this number from this number. But the problem here is that the number that we're subtracting, this fraction in the mixed number, 5/6, is greater than 3/8. And the way that I know this without doing much math on the side, at least the mental math that I'm doing, the math that I'm doing in my head, is I think about 5/6. I know that this is greater than 3/6. Okay, because the numerator is greater and they have the same denominator. And 3/6 is equal to a half. So this tells me 5/6 is greater than a half. But I also know in the same thought that 3/8 is less than 4/8, and 4/8 is equal to a half. Okay, that was the fraction we talked about before, but 4/8 simplifies to a half. So if 5/6 is greater than a half and 3/8 is less than a half, that's how I know 5/6 is greater than 3/8. So that tells me that I'm going to need to do some borrowing here. Now, another concept that may not be obvious is that 3 3/8 is actually the same thing as saying 3 plus 3/8. Okay, these have the same meaning here. But with mixed numbers, you just squeeze these two together and just say 3 3/8. And the reason I want to mention this is I'm going to break this up. I'm going to call this 2 plus 1 plus 3/8. Okay, and then minus 1 5/6. And the reason I'm allowed to do this because 2 plus 1 is 3. And then once again, 3 plus 3/8, I could squeeze back to this form here. But what I want to do is I want to turn 1 into a fraction with a denominator of 8. So I'm going to call 1 8/8. And this is fine because 8 divided by 8 is 1. So that would bring us right back to the line before it. Okay. Now, if you just know the technique here to borrow from here and then turn this into 11/8 so you could do the subtraction, then great. But I'm just showing this is more the concepts of what's happening when we borrow. Okay. We're using this idea that mixed numbers could actually be expanded like this. So now what I'm going to do is combine these two. I'm going to have 2 plus, and then 8 plus 3 gives me 11. And the denominator we just keep as 8 like this, minus 1 5/6. So now I'm going to write this over here in mixed number form. I have 2 11/8 minus 1 5/6. But the problem here is that we don't have common denominators. So now we have to find the least common multiple between 8 and 6. And that would be 24. Okay, so I'm going to multiply this fraction by 3/3. And I'm going to multiply this fraction here by 4/4. So now the whole number I leave alone. So I have 2. 11 times 3 is 33 over the denominator 24. Minus 1, and we have 5 times 4 is 20 over 6 times 4 is 24. And now I'll just subtract these two on the side. 33 minus 20 is going to give us 13. And what I'm going to do now is I'm going to subtract the fractions and I'm going to subtract the whole numbers. So I do 2 minus 1 is 1, And then 33 minus 20 is 13. And the denominator of the mixed number is 24. So this would be the difference here, 1 and 13/24. Choice A is our answer. Question 34, which statement about a rhombus and a square is always true? So for this one here, I'll just go through the answer choices one by one to find the true one and try to argue why the ones that are wrong are actually wrong. So here for A, we have both shapes are parallelograms and have 4 equal sides. This one here is definitely always true. If you think about a square, we have all 4 sides are equal and it has 4 right angles, but this is definitely a parallelogram because the opposite sides of the square are parallel to each other. Okay, so the ones that are across from each other are parallel. So a square is definitely a parallelogram and all 4 sides are equal in measure. With a rhombus, this is kind of like a slanted square. You could think of it like this. All 4 sides are equal in measure, and it's a parallelogram because both pairs of opposite sides are parallel. So choice A is definitely it. Now, why is choice B no good? Because anytime you get choice A is the one that is always true, you should, if you have time, go through the remaining answer choices and try to argue why those are no good. So now let's go through the other answer choices to see why are those no good. Well, if we look at choice B, both shapes are parallelograms that have 4 right angles. But if we think about the rhombus once again is a slanted square like this. And notice that this angle over here is clearly not 90 degrees. Okay, this one here is an acute angle. It is less than 90. So this shape does not have 4 right angles. So that is not true for the rhombus and the square. A square has 4 right angles, but the rhombus that I just drew here does not. Now we have next, both shapes are quadrilaterals. That's true because they both have 4 sides with exactly 2 acute angles. This is not true. Yes, the one that I drew for the rhombus has 2 acute angles, but a square has no acute angles. Okay, it has 4 right angles, and right angles are neither acute nor obtuse. Okay, so the square will contradict or make choice C not true. And now we have for choice D, both shapes are quadrilaterals with exactly 1 pair of parallel sides. That is not true. Both shapes are quadrilaterals with exactly 2 pairs of parallel sides. Okay, both pairs of opposite sides are parallel for both the square and the rhombus. Okay, so that is why choice D is no good. Choice A is definitely our answer. Question 35, we have a cook in a restaurant has 13 gallons of milk, and we want to know how much milk in quarts does the cook have. So for this question, we have to know that 1 gallon is equal to 4 quarts. Okay, so for every gallon that we have 4 quarts. So for this one here, what we could do is multiply. You could see that the amount of quarts is 4 times greater than the amount of gallons. So here I could just take 13 and multiply by 4, and that's going to tell us how many quarts we have. So 4 times 3 is 12. I carry the 1. 4 times 1 is 4 plus 1 is 5. So we would have 52 quarts. Now, something a little bit more advanced that you're going to learn later, if you just want a sneak preview of the next few levels of math, unless you learned this already, then great. But 13 gallons, if I'm converting to quarts, I could just multiply by 4 quarts over 1 gallon. And the reason I'm allowed to multiply by this is since 4 quarts equals a gallon, when you divide equal things, that quotient simplifies to 1. Unless you're dividing by 0, but don't worry about 0 divided by 0 for a while. Okay, if I did something like, let's say 5 divided by 5, this I could express as a fraction as 5 over 5. And once again, when I have equal quantities in my numerator and denominator, that simplifies to 1. Okay, so when I write equal things in my numerator and denominator, this is really just a fancy way of saying 1, even though 4 and 1 are not equal numbers, but the units make these terms here on top and bottom equal. And now notice that gallons over gallons cancels out. Okay, when you have matching numbers or units on top and bottom, they cancel and they make 1. So that's why we're doing 13 times 4 to get 52. And then the units at the end would be quarts like this. Okay, so choice D is definitely our answer. So now we're moving on to the free response questions. And for question 36, we have the height in inches of 4 towers made from toothpicks are shown below. And we have to write a number sentence comparing the heights in inches of the 2 tallest towers. Okay, so we want the 2 tallest towers here. And we have to be sure to include the symbol. We have greater than, less than, or equals in our answer. So the first thing we have to identify here are the two biggest numbers, or the two greatest numbers in the list, because this is modeling the heights of 4 towers made of toothpicks. Okay, so the biggest numbers in the list, first I look before the decimal, and notice we have 33, 33, 29, 33. So 29 is out. So now we look at the 33s, and now we look after the decimal, and we have the tenths place. So we want the biggest numbers in the tenths place. So the two biggest numbers in the list are going to be these two numbers here. Okay. Another way to think of this, just imagine that these were whole numbers. If you just move the decimal over for all of them, and you think of 331, 332, if you had 293 and 333, the biggest numbers in the list might be way more obvious now. Okay, so just looking at this, I would say, oh, these are the two biggest numbers. So that's why these are the two biggest numbers if we just move the decimal over. But now we have to think about writing a number sentence that compares these two numbers. So the smaller number is 33.2. This number is less than 33.3. Okay, now this is the less than symbol. One way to remember it is I just think of the Pac-Man guy, okay, or you could just think of this as a monster. I don't know if Pac-Man is still relevant, but we have 33.2 is less than 33.3. And you just imagine that this symbol turns into a monster like this, or some creature that wants to eat the bigger number. Okay, so that's what I imagine still to this day, all these years later, is that this creature is going to want to eat the 33.3. So that's the direction that the mouth is facing. It wants to eat the bigger number. So we could say 33.2 is less than 33.3. Now, just know there is another way to write our answer. We could also say that 33.3 is greater than 33.2. Question 37, we have Andre is using a 15-foot piece of ribbon for an art project, and he cuts the ribbon into equal-sized pieces, 1/3 foot in length, and he's using all of the ribbon, and we want to know how many pieces of ribbon does Andre cut. Well, if there's 15 feet in total, and he's making cuts that are 1/3 of a foot in length, we're going to do 15 divided by 1/3. And anytime you want to divide by a fraction, you could use the technique keep, change, flip. So we keep the first number 15, we change the operation to multiplication, and then we flip the fraction to 3/1. And now just know here, 3 divided by 1 is 3, so we're going to do 15 times 3, and this tells us that there are 45 pieces of ribbon. Okay, that's how many pieces that Andre is going to cut. So our answer to 37 is 45 pieces. Question 38, we want to know what is the volume in cubic inches of the cube shown in the diagram below. Now, one thing we have to know here is that with a cube, all of the sides are equal in length. So if the height of the cube is 6 inches, that means that the length is also 6 inches. And we could also say that the width is 6 inches as well. So if we want to use this formula, volume equals length times width times height, we could use this formula. And just know, once again, that the length, width, and height is the same when we have a cube. So I'm just going to do 6 times 6 times 6. Okay, so we're going to do 6 times 6 times 6. And the units here are cubic inches, but we don't actually have to write it when we're showing our work. We could just write this at the end. But the way we write cubic inches is we write inches to the 3rd power. So now, first I would do 6 times 6 is 36. So this is going to work out to 36 times 6, and then we have cubic inches. Okay, so I'll just do that long multiplication on the side now. So 36 times 6, I'm doing 6 times 6 is 36. I carry the 3, and then I have 6 times 3 is 18. 18 plus 3 is 21. Okay, so this product is going to work out to, we're going to say over here, 216. Okay, so we have 216 cubic inches. This is the volume of the cube. So the answer to 38 is 216 cubic inches. Question 39, we have Josiah makes a total of 195 ounces of lemonade, and he pours the lemonade into 16-ounce bottles until each bottle is full. And we want to know what is the greatest number of bottles Josiah could fill completely with the lemonade. So for this question here, what we're going to do is we're going to take the total amount of lemonade. We're going to take the 195 and we're going to divide by 16. Okay, because what Josiah is doing here is he's taking this total amount and he's dividing it up into 16-ounce bottles. So we want to see how many groups of 16 we could make here. So that's why we're going to divide by 16. So 16 goes into 19 once. 1 times 16 is 16, so we subtract, and we get a remainder of 3 here. And now we carry down the 5, and 16 goes into 35 twice. If we do 2 times 16, we're going to get 32. So when we subtract, we have a remainder of 3. So our remainder, we're going to write over 16 like this. But we have to think about this very, very carefully. We want to know what is the greatest number of bottles Josiah could fill completely. Okay, so that means that the remainder we're going to ignore. So we're going to say here that Josiah could fill 12 full bottles. Okay, so that is how many bottles Josiah could fill. So we'll just write our answer over here. Josiah could fill 12 bottles. Question 40, we have a multiplication problem is shown below, and we have 42 times 5/8. And then we have a student claims that the product will be greater than 42. And we want to know, is the student's claim correct? And we have to explain without actually calculating the product. So for this question here, we want to think about what happens when we multiply two numbers. So I'm thinking of, for this question, if I had something like 42 times 1, that would just give me 42 again, okay? When you multiply by 1, you're going to get the same number that you're starting with. If I did 42 times 2, this would give us 84, okay? I'm just doubling 42. But if I did something like, let's say, 42 times a half, I take half of 42, I get 21. So the trend here is that when we multiply by a number greater than 1, that makes our term here bigger, okay? Since 42 is a nice positive number, when we multiply by a number bigger than 1, it's going to make the number greater. When we multiply by a number less than 1, that's going to make the number smaller, okay, or less than. So that's how we could say here that the student is incorrect. The student is incorrect because if we look at 5/8, 5/8 is a number that is less than 1, okay? So if we take 5/8 of 42, that's going to result in a smaller or a number less than 42. Now, one thing to mention here is in this explanation, we are mentioning that we are multiplying 42 by a number that is less than 1, okay? So that is the reasoning we are using to say that this product is going to be less than 42. Question 41, we have a diagram of a three-dimensional figure shown below, and we want to know what is the volume in cubic centimeters of the figure, and we have to show our work. So for this question here, we have two rectangular prisms. So we're going to use the formula volume equals length times width times height. And the two rectangular prisms, I'm just going to draw this line in here so we could see that we have one rectangular prism going this way. So this one here, the shorter one. And then we have the tall rectangular prism over here. Okay, so these are the two volumes that we have to find, and then we're going to add them together to get the total volume of the figure. So what we have to make use of here is this entire distance is 7 centimeters, but we're told that the length of the tall rectangular prism is 3 centimeters. So if this length is 3 centimeters, that means that this length over here is also 3 centimeters. Okay, so I'll just highlight this. If we have 3 centimeters going this way, then I would have to say that this distance over here is also 3 centimeters. But now notice that the entire distance from here to here is 7 centimeters, and this distance is 3 centimeters. So if I subtract 7 minus 3, that tells us that the length here is 4 centimeters. Okay, so the shorter rectangular prism, the length is going to be 4 centimeters. And if we were to add here 3 plus 4, that would give us the entire distance 7. So now we have the length, width, and height of the short rectangular prism, but we need the length, width, and height of the tall one. So we have the length, we have the height, the width is going to be the same width as the width of the short rectangular prism. Notice that they're both going the same distance back like this. So I could say this distance over here, I'll label this as the width, is 2 centimeters. Okay, so once again, it's going the same distance back as this one down here. So now I'm going to find the volume of the figure. Okay, so we have the volume of the figure, and we're just going to work this part out over here. So we have the volume of the figure is equal to, and I'm just going to put this all in parentheses. So I'm going to find the volume of the tall one first. So we have the length is 3 centimeters times the width is 2 centimeters and the height is 6 centimeters. And then we're going to add the volume of the shorter one. So the length here is 4 times the width is 2 times the height is 1. And the units here are cubic centimeters. So I'm just going to write that on the outside here. and just worry about working out the numbers on the inside. So now I just have to do this multiplication and addition. So here it helps to know order of operations. So I'm going to write out PEMDAS. And the way we remember this is please excuse my dear Aunt Sally. And on the inside, we have multiplication and addition. And notice that multiplication shows up before addition. So we have to multiply these sets of numbers before we add anything together. So we're going to say the volume now is equal to, we have 3 times 2 is 6, and then 6 times 6 is 36. So I have 36 plus, and then I have 4 times 2 is 8, and 8 times 1 is 8. And then the units here are cubic centimeters. But now I just have to add 36 plus 8 is 44. So the volume of the figure is 44 cubic centimeters. So we'll just record our answer. Our solution is 44 cubic centimeters. Question 42, we have a student writes 67.203 in expanded form as shown below. And then we have the student made an error. So what we have written here is incorrect. And we want to know where did the student make an error. As part of our answer, we have to write the number in the correct expanded form. So what I'm thinking about here is I'm thinking about the place value. So the 6 here, notice, is in the tens place. And then we have the 7 is in the ones place. And if I write out a few more, the 2 is in the tenths place. And then we have the hundredths place. So hundredths. So this is a little bit tricky to spell and say. And then last we have the thousandths place. Okay. So if I look at these numbers, so 6 is in the tens place. So notice we get 6 times 10, which makes sense. 7 is in the ones place. So we get plus 7 times 1. That also makes sense. Then we have 2 is in the tenths place. So we multiply 2 by 1/10. So far, so good. And then now here's the problem. Okay, here's the mistake. 3 times 1 over 100. But notice that 3 is in the thousandths place. Okay, so what should have happened, what I'm thinking about right here, is that should have said 3 times 1,000. Okay, because it is in the thousandths place. So that's the correction that we're going to have to make here. And that's what we're going to include in our explanation. The student made an error and their mistake was they did 3 times 1 over 100 instead of doing 3 times 1 over 1,000. And then after this, we could write the correct expansion. So we have our explanation and we have the correction here. Remember, we are switching 3 times 1 over 100 to 3 times 1 over 1,000. Technically, the hundredths place, we could say there's a 0 times 1 over 100, but we don't have to indicate 0 times 1 over 100 because 0 times 1 over 100 is equal to 0. So that's not going to change the value of our expanded form. So here in red, we have the correct expanded form. Question 43, we have Adam opens a half-pound can of tuna and he uses all the tuna to feed his cats. He puts an equal amount of tuna in 4 containers for his cats, and we want to know how much tuna in pounds is in each container. Well, in total, Adam has half a pound of tuna. Okay, so we have half a pound of tuna, and he is sharing it equally amongst 4 containers for his cats. Okay, so we're going to make 4 equal groups, so we're going to divide by 4. And remember from before, the technique we're going to use is keep, change, flip. Okay, so I'm going to call 4 over 1. And now I could rewrite this as we have half a pound and we're multiplying by, so we're doing keep the 1/2, change the operation to multiplication, and we flip 4 over 1 to 1 over 4. And now from here, I just multiply the numerators together. I have 1 times 1 is 1. And then my denominator is going to be 2 times 4, which is 8. Okay, so that means each cat, or how much tuna in pounds is each cat getting in their container? We're going to have 1/8 of a pound in each container for the cats. So our solution here is 1/8 of a pound for each container. Question 44, our last question, and it's 2 parts, but first up, we have the line plot below shows the recorded amount of rain that fell in a city during the month of April. So what we want to find here is the total amount of rain in inches recorded in April. So for this one here, there's a few ways we could go forward with this, but one way would be to just write down all of these values. Remember, each X represents the number that it lands on. So if we have 3 x's on 1/8, that means that in April, so far we have 1/8 of an inch plus 1/8 of an inch plus 1/8 of an inch. So I could just do repeated addition here, and this would be one way to get to our answer. If you would rather not do repeated addition, one thing you could do is use multiplication. You could say that 1/8 shows up 3 times. So I have 3 times 1/8. And then I also have, so I have plus 2 times 1/4. And then next we have 3 times 3/8. Okay, so plus 3 times 3/8. I'm only doing this so I don't have to write out a crazy long sum. This is still going to be a long sum, but it's not going to be as bad as if I didn't use multiplication. So now we have 1/2 showing up twice, so 2 times 1/2. And then we have next 3/4 shows up 3 times. We have 3 times 3/4. And then we have 7/8 showing up once. Okay, and now for this, what we could do is when you multiply a fraction by a whole number, you just have to multiply the numerator by that number. And the way to see that is I could call 3 over 1. And I'm going to do 3 times 1 is 3. And then in my denominator, I have 1 times 8 is 8. Okay, so this is just going to help us simplify. So 2 times 1 is going to give us 2, and we're over 4 here. And then 3 times 3 gives us 9, so we have 9 over 8. And then next we have 2 times 1 is 2. So this is going to work out to 2 over 2. Remember, I'm just multiplying the whole number by the numerator. And then I have plus 9 over 4 after I do 3 times 3 over 4. And then plus 7 over 8. And now the next thing I'll do here is find common denominators. So I would want all of these denominators to be equal to 8. So this first fraction we can multiply by 2 over 2. This fraction over here I would multiply by 4 over 4. And then this one I would multiply by 2 over 2. And now we simplify, we have 3 over 8. And now we're going to add 2 times 2 is 4. And we're over 8 again. And then we have plus 9 over 8. And then next we have 2 times 4 is 8. So we have 8 over 2 times 4 is 8. So we're expressing 1 as 8 over 8 just so that we have common denominators. And then 9 times 2 is going to give us 18. So we have 18 over 8. And then we have 7 over 8. So now we just have to add all of these numerators together very, very carefully. So we have 3 plus 4 is 7. And then we have 7 plus 9 is 16. 16 plus 8 is 24. And then we have 24 plus 18. That's going to give us 42. If you have to do some of this on the side, like 24 plus 18, if the mental math is just too much, I would recommend that you do some of the addition on the side. So this is going to give us 42 once we do 24 plus 18. And now we're at 42. 42 plus 7 is 49. So we're at 49 over 8. So now for this, I would do the long division on the side. 49 divided by 8, and I'll write this in long division form. 8 goes into 49 6 times, and then 6 times 8 is 48. I subtract 48, and I get a remainder of 1. So I have, and I'll just move this down a bit, we'll make space. So this long division question, we'll just move this a little bit out of the way. So if we work this out now, we have a remainder of 1, and we were originally dividing by 8. So this simplifies here to, we could say this equals 6 and 1/8. Okay, so we have the total amount of rain in April was 6 and 1/8 inches. So now for the final part of this question, we have the total amount of rain that fell in the city during the month of August was 8 and 1/4 inches. And we want to know what is the difference in total rainfall in inches between August and April. Well, what we have here is we have the April rainfall and the August rainfall. So we're just going to subtract them. Difference means to subtract. So we have 8 and 1/4 minus 6 and 1/8. Now, for this one here, what we could do is we could find common denominators for these two fractions. And I could get that just by multiplying this first fraction here by 2 over 2. So I'll just make a little bit of space here. So we're going to subtract, but I'll make space so that we have room to make common denominators. I'm going to multiply this first fraction, 1/4, by 2 over 2. So now this turns into 8 and 2/8 minus 6 and 1/8. So now notice here that 2/8 is greater than 1/8. So I'm not going to run into any problems here with subtracting. If the fractions were reversed, if I was doing 8 and 1/8 minus 6 and 2/8, then I would have to borrow from the whole number like I did earlier in the test. But for this question here, they were polite. They gave us one where we don't have to borrow. So we have 8 minus 6 is 2. And then we have 2/8 minus 1/8 is 1/8. Okay, I'm just doing 2 minus 1 is 1, and I keep the denominator the same. So the difference in total rainfall in inches is 2 1/8 inches.